Hi, everybody. Welcome to the AI and Enterprise workshop series that the Laboratory for Information Science at Harvard has kicked off. My name is Kareem Lakhani. I think I know many of you, but there's also new folks as well, so looking forward to getting to know you as we get this going. I'm a faculty member here at HBS, a founder of LISH, the Laboratory for Information Science, as well as founder and co-director of the Harvard Business Analytics program. I'm on brand, as you can see. We get a note from our dean to always be on brand, so I'm on brand. Anyway, this workshop series comes about because at the lab, as well as in much of the activities that we've been doing at HBS, we've focused a ton on AI and the applications of AI in organizations and businesses. And there's been a lot of attention on sort of AI and sort of big tech firms, and that's a great place for us to learn. But for the rest of us who are not in big tech firms, how we think about the deployment of AI enterprise is going to be a crucial question going forward. As some of you know, we've written a book about this, and we think a lot about how AI impacts both business and operating models. And so these workshop series, in fact, are geared to really focus in on ways in which AI can be deployed in the enterprises across the board, not just in big tech. Just a bit of the history of the series. We had initially planned these as in-person events. But now as COVID has hit the entire universe, we're all doing these virtually. What's nice about these types of virtual events is that we can achieve scale that's unprecedented. So I think when we had our first workshop series back in the fall of 2019, we had about 50 or 60 participants, and already I see we have about 180 people that have joined us, and so the scale here is quite good. Of course, we can't run a whole day on Zoom. We're going to do this bite size, so just this 1 hour today. But we hope that you will join us on a monthly basis as we do these exercises. And I've chosen these speakers selfishly because I want to learn myself. I think we're all in the learning journey together, and I find that trying to work with the best out there on this topic is going to be great. I want to thank a few people from the lab before we kick off. I want to thank Jenny Hoffman, who has been behind the scenes making sure that this all worked out, Stephen Randazzo from the lab, Jen Paik from the lab, and then our entrepreneur in residence, Doug Levin as well from the lab, who's been helping us conceive of these events and do the outreach we need to do. Before we begin and I introduce our speaker to us, a few housekeeping items. The first one is that just make sure your microphone is muted. I don't want to run this as a webinar because then we never see you and can't interact with you. So just, so I want to have everybody participate, but just please make sure that you're muted. You can submit your questions by typing them into the chat for this meeting. And then as we see these questions pop up, I'll select on a few people to make the requests for these questions. And then we're recording this session both as a video and later as a podcast. And so shortly after we end, you'll receive an email with information on where you can find these recordings, and you can also hopefully share them as well. The next email will also include information for registering for our next session, which is with Peter Skamorok, who is a machine learning executive and entrepreneur with experience at Workday and LinkedIn, and we'll really focus in on data wrangling as the big next step. So that'll be on Wednesday, July 15th at 11 a.m. Eastern. And then finally, of course, the email will give us an opportunity to tell us how much you love us or how much you want us to improve, and we'll take that from you as well. So, okay, so without further ado, I'm really delighted to introduce our first speaker, Rob May. Rob has agreed to kick us off and sort of address the big topics that we see going forward. Rob is a general partner at a VC firm called PJC and writes InsideAI, one of the most widely read newsletters on AI. His expertise spans AI, hardware, B2B, and SaaS models. Prior to joining PJC, Rob was a co-founder and CEO at Tala, an AI automation platform. And then also he was the co-founder and CEO of BackupFi, the first cloud-to-cloud backup provider, which was acquired for over $100 million. Rob's also an angel investor, and he's made more than 70 early-stage AI investments. So Rob, thank you again for taking the time, and let's get going, Rob.
Yeah, thanks for having me. I'm glad to be here.
So Rob, why don't you just kick us off by giving us a big picture and walk us through what you sort of see as sort of the reasons why there's so much excitement around AI today and what's going on.
Yeah, so I've got a couple of slides here that I'll share as to help answer some of the questions that we talked about, and I'll start here with this idea of what's changed, right? You've heard about AI for years being interesting technology. You know, it started in the 50s. There've been a bunch of AI winters, as they call them. So like, what happened to make all this suddenly real, in a sense, and have real applications? And it's a combination of a couple of things, right? Data sets, GPUs, and convolutional neural networks. And so what I mean by that is, here you can see the success that AI's had. So in 1956, Marvin Minsky, who was a professor at MIT, gave a grad student the project of, hey, apply AI to machine vision and have it identify images as well as a human. So you can see that by 2010, right, which was almost 60 years later, we were 78% accurate at doing that, like not very good at all. And then between 2010 and 2015, we got to 95% accurate. So why for 50 years did we make so little, such slow progress, and then in 5 years made so much progress that we were as good at humans at that basic thing? And that really came from three things that happened. Number one, a lot of the approaches there are lots of ways to do AI, not just neural networks. And the people that were toiling away on neural networks actually didn't get much credit, right? Symbolic logic processing, genetic algorithms, there were other, expert systems, there were other forms of AI that were important, that were being focused on. And in 2010, neural networks, particularly convolutional neural networks for vision, really became popular and successful, as you can see from this chart. And the reason they did was because you suddenly had very big data sets which appeal to neural networks. So in particular, there's one that came out of Stanford called ImageNet, which was the largest data set of images collected and labeled at that point in time. And the second was people started to learn to program neural nets with GPUs. So if you think about a computer, it has two parts: the CPU, which runs a set of instructions, and the GPU, which doesn't run serial instructions but controls the screen. So what it does is it does 1 million instructions, the same instruction 1 million times in parallel. And some smart grad student figured out, wow, that's sort of how a neural network works. I could hack that GPU to program my neural network, and instead of taking 5 days to program it, it takes 5 hours to program it. And so those things combined really led to this current wave of AI, and that's why you're seeing all the success in the last couple of years.
So great, Rob. So walk us through your framework, which I thought was quite interesting in terms of how to think about where we're seeing AI applications in enterprises.
Yeah, so one way to think about neural nets, in particular in AI, and the way that they work well is when you have problems where you kind of know and understand the rules to do something, but there's so many that it would take you forever to write a computer program, and there would be a lot of exceptions. Hey, if A happens, do B. Unless C happens, then do D. You have a lot of complicated rules like that. Those are really good problems for AI to solve, because if you have these big data sets, you just give the data to the neural network, and the neural network figures out all those rules for you way faster than a programmer could write it. So, but that's a sort of technical explanation, but you still get into this challenge of, well, how do I implement it? Like I run an insurance company, or I'm a VP at a car rental company. Like, what can I do to implement AI? And I get that question a lot. And so I typically walk people through this, what I call the PAC framework. Now, if you have any kind of science background, there's a PAC algorithm called probably, approximately, correct. That's not what we're talking about. So don't get confused. This stands for, as you can see on the right side of the screen, predict, automate, and classify. There's lots of things that you can do with AI, But these three things in particular, AI is really, really good at. It can predict things given a big data set of previous things that happened. It can automate things that a human used to do, or it can classify things. Hey, I have a couple of categories of things. Which category should this go in? And so I wouldn't try to get too fancy to start, because then your projects are going to fail. And so if you want to start simply, I would look at predict, automate, classify, and then I would look at three parts of your business: customers, products, and operations. And I would say, how can I create a matrix and think about, how do I predict things about my customers, right? How do I automate things about my operations and all that kind of stuff? And so,
Hey, Rob, as I think about, if you go back to the last slide, as I think about the PAC framework, I mean, I think what's interesting is, in the enterprise, people are predicting all the time, right? Like, I mean, that's why we hire managers, right? To make some predictions about some future outcome, right? About, what kind of customers will show up, what kind of things, which machines might fail, so on and so forth. So prediction in many ways is like a pretty common task in enterprises, and also classification, right? In the sense of, like, we're always trying to figure out, how do I recognize patterns in my data? How do I think about certain types of employees, certain types of products, and so forth. And so it seems to me like in most of the enterprises we work with, prediction and classification are two tasks that almost all managers and employees are engaged in, one way or the other. Automation is more new, but it seems like those two things are rampant in most enterprises.
Yeah, that's a good point. And there's actually, if you want to learn more about this, there's not a lot of good books written yet on AI strategy, but we're getting there as people understand it better and better. But there's a good book that came out maybe a year and a half ago, maybe a little longer, called Prediction Machines. And it was written by some economists, and it looks at the idea of, well, from a business perspective, if you can use AI to predict things and the cost of prediction goes down, what does that mean for your business, right? It means that you can predict things that you couldn't predict before. You can apply AI to make predictions that you might not have done in the past because it was too laborious to get the data or make the prediction or whatever. And so then what complements to prediction go up? Well, judgment goes up in value, because now you're making all these predictions, but they're probabilistic, right? They're not 100%, even when humans do them, but let alone when machines do them. And so if you have a machine spitting out 88% chance of this, 92% chance of this, 97% chance of this, how do humans deal with that? Using judgment to know when to go against the machine, or how to integrate the prediction with other steps in a workflow, is a pretty powerful thing. So I would encourage you to check out that book. Again, it's called Prediction Machines. And so this is how I would make a chart like this, and think about the different areas. And you might not have everything, depending on your business, to go in every box, right? But can you automate, for example, for your customers, could you automate call follow-up? Maybe you want to do that, maybe you don't. This is really just a brainstorming exercise for areas that you could apply AI. Could you classify which customers are most profitable? There's a really interesting startup in Boston, I'm blanking on their name right now, but they're working on these AWS and Azure models. And there are a lot of companies that help you control your cloud spend, right? Oh, you're using too many EC2 machines. Let's consolidate those and run those down. This company does it really interesting. They use AI to classify which product features drive the most machine usage. So they might say, hey, you launched that new feature in your application, and it didn't lead to a lot of extra sales, but the people that are using it, it's leading to a lot of infrastructure charges. So the ROI on that particular product feature may not be very high. And that's the kind of thing that was really difficult to do before. So, when you make this framework and you apply it to your business, this is to generate ideas, but you have to take the next step from here and start to think about, well, number one, can you do it, right? Do you have the data to do whichever thing in whichever box that you want to execute on for your business? And then also you have to think about, using sort of classic business strategy. Like, does it matter? Is it part of your core competency? Like, is this something you need to be good at or want to do? When you find these areas where you can use AI to really double down on the things that you're already good at, the things that already differentiate you from your competitors, those are the best places to start, right? But that's not what's happening today. What's happening today is AI is being adopted in companies a little intermittently, where You just have this one forward-thinking executive who's like, hey, I want to try some AI over here on my thing, which may or may not be the right thing for the business. So,
Hey, Rob, just on that, if you go back for a second, this whole adoption story that you sort of mentioned, like, you know, what are some of the problematic adoption strategies executives have? Because I often find in talking to companies, it's like, you know, the first AI project is going to be like create anti-gravity. You know, they're trying
yeah.
to basically solve for the world. But what have you sort of seen in both your startup experience and with enterprises about sort of the common pitfalls that executives have when even starting to do a pilot, let alone everybody gets trapped in pilot hell? But what do you see as some of the wrong assumptions people make about AI and AI adoption in enterprises?
Yeah, that's a great question. So there's a lot of challenges, right? One is that, like you said, people want to apply to this magic problem, like, oh my gosh, if we could just do this thing, and it's not magic, right? You know, if humans can't do it, the machines probably can't do it from an AI perspective. So we'll, you know, they will surpass us someday. I don't know when that day will be. Not anytime soon. You know, and then you have a lot of cultural challenges. So sometimes people don't want to change their, you know, their behaviors and their workflows. But there's two really big ones, right? One is people don't think about re-engineering their workflows for AI. They think about it as a tack-on technology. So here's the example I like to give. Before the internet and before the World Wide Web came around, companies had a graphic design process. They used it to make brochures, they used it to make flyers and all that kind of stuff. And so there were a lot of companies in the mid to late 90s that used that workflow and said, oh, we need a web page. Let's use our graphic design process to generate a, you know, a piece of paper that shows our web page, and let's hand that piece of paper to a web developer and say, make a web page that looks like this. But it's entirely wrong, right? Because the web is not a static piece of paper. You can have dynamic text, you can have hyperlinks. Earlier parts of the workflow, the design workflow, before you get to that printed out page, need to be addressed with the web mindset, right? Of, wow, you know, if you can link, you need to think about an information architecture and stuff like that that you didn't think about when you just were making flyers. And it's very similar with AI. So people have an existing workflow and they say, great, let's lump some AI on the end of this workflow and let's see what happens. And like, that might get you a marginal improvement. But if you can actually go back and revamp your workflows to do things like collect better data, annotate the data, have feedback into your AI models, right, as they're coming out. Train your employees culturally to understand that instead of getting a binary yes/no output, now you're getting a probabilistic output. And so what does that mean? Those are some of the things that you have to do from a cultural perspective. From an economic perspective, the biggest barrier is that, you know, people expect these projects to look like software projects from a margins perspective. You know, we see this as a venture investor. I'm always looking at, I mean, I love these SaaS companies that have like 88, 90, 92%, you know, gross margins. It's beautiful. Most AI companies, I haven't seen an AI company yet that has that. You know, a lot of them start with a lot of services component to it. There's humans doing some pieces of the task. You know, you're trying to deliver a full stack solution, and humans are, you know, AI is doing part of it, but humans are still doing part of it. And so your margins look more like services margins. And so you go, you know, if you're a software company, you don't want to invest in that. You really have to work, and we've seen this, right? As you automate more and more, and your data sets get better, and your team gets better, you start to look more like software margins. So I'm an investor in a company called BotKeeper that does automated bookkeeping. And so the way that it works is, you know, instead of hiring a bookkeeper, if you had a remote bookkeeper, you would just email, you know, Susie Smith and just send her stuff. Well, now you email Susie@botkeeper.com. You get responses and things happen. Your books get done. It happens way faster with way more accuracy than if you use the human. And it's part human, part machine. And a lot of investors, when I first invested in 2016, a lot of investors that I talked to sort of passed and like, this looks like a services company. You know, they had 100 people in the Philippines that were doing the accounting work, but they were recording the tasks that the accountants did. And they were using the data sets when they got big enough, because you need a lot of data to train AI models. When they got big enough, they would automate the next task because they had enough data now. It's one less thing the humans have to do. And so, you know, their margins have gone from, you know, 42% gross margins to the next year they were 58%, to the next year they were 64%. And, you know, now they're in the 70% range. They'll get in that 80% SaaS, you know, SaaS range, but it's one of the challenges that you have to bite off if you're going to apply this in your business.
Hey, Rob, just a related question that has popped up as well. Ali asked this question about, we've had, the pack framework in businesses all the time, as we discussed. So what especially does AI bring that humans or other mechanisms before weren't able to do in the realm of business? Just to contextualize that, because I think part of what we see happen is that, beyond the fans of AI or those that want to learn about AI who get this, like, how do we translate why PAC is so powerful, why AI is so powerfully applied to the PAC framework?
Yeah, so I would think about it this way. One is AI can take data sets and figure things out from a data set that your average human couldn't. So to give you an example. Your average bookkeeper in an accounting department is 89% accurate in how he or she classifies things. And the algorithm, so BotKeeper right now is 98% accurate. And so that difference comes from a situation like this. Let's say that you are in a mid-sized business and you have servers on premise, but you order a lot of office supplies from Amazon. And so when Amazon bills come in, those get classified as office supplies. And then suddenly your bookkeeper, who doesn't know much about technology, sees that you've moved to AWS and sees this server bill. And it's like, oh, it's an Amazon thing, office supplies, right? And it gets miscategorized. That happens a lot in businesses, right? And if you've ever been CEO of a small to mid-sized company, or CFO, you get these spreadsheets at the end of every month about, like, well, how do I classify these things? Well, an automated algorithm can look at that across thousands, tens of thousands, hundreds of thousands of businesses at once. And if one business somewhere has classified it some way, it now can know how to classify that. It can also figure out by industry, you might classify things slightly differently, right? So AI brings that. And then one of the ways to think about AI algorithms is most software you build and you put it out in the world and it does the thing it was designed to do. Sometimes it has bugs, but in general, it does what it's designed to do. AI algorithms learn and interact with the world. So when you put an algorithm out there, when you put an AI product out there, it's going to change over time based on its interaction with the world in terms of how it works. And that's what's really important. So you can put it into situations like, the last company that I ran before I became a VC was called Tala. Tala did customer support automation. So if you've ever seen one of these chatbots on a website that pops up and answers questions, and so that was used by a lot of companies to, deflect, like, there's a bunch of questions that just come up and they're simple and people they can't remember, the simple thing that they need. And that's a great thing for a chatbot just to automate. And what happens is over time, as more and more things come in, if you build an interface where as the human resolves the question, then the AI starts to learn that from the interactions with the support agent. So we automate more and more and more and more of the customer support interactions. We'll never get to 100% until AI is smart enough that it can figure out a new solution on its own the way that a human could. And that's probably, 15, 20 years away. But we saw deployments at companies where they saved $2, $3, $4 million a year in support costs because they could run with way less staff than they eventually needed. They could redeploy those people to other areas, or they could scale without hiring a lot of additional heads.
So to summarize, you would say there's like the scale advantages, the accuracy advantages, right? And then inherently in there's also the sort of the speed advantages that these things can enable for us.
Yes. Yep. Great. And from a strategic perspective, when you think about applying them to the core of your business, sometimes you'll find these really nice areas where you have a little bit of a flywheel, right? Where if the performance of your product depends on AI algorithms that require a lot of data, and you get going first and you have the most data, then you have the best product, right? Because your AI model is the best, trained on the most data. That means you get the most users. And then that perpetuates itself. So it can be pretty powerful.
Right.
Should I keep going on implementation?
Yes, please. Stuff? Of course, Rob. Yeah.
All right, sure. And this is just because sometimes people ask for a specific thing. I don't know much about Snapchat. I'm not a Snapchat user. It's part of the reason that I chose this specific business, but you can see how Snapchat might apply this, right? So if you apply it to your business, you may not have something in every box, but that's something that you could, that you could think about. And these are the questions that you have to ask if you're going to do something like this, right? Number one, what's the ROI? Because like any other business project, sometimes there are things that would be really cool and fun to do, but the cost to do them is just massive because you don't have the data, or the data is not in the form that you need. Do you have the data to do it, right? You know, I mentioned before, one of the directions AI is going to go is in, we have to solve this problem of working with small data. Like those of you that have children know that, you know, you don't have to show them 10,000 examples of a coffee cup before they get what a coffee cup is. You show them like three coffee mugs and they're like, I got it, that's a coffee mug. AI is not there yet. We need a lot of examples and a lot of data. And you have to understand, does the data set drift? So an example is if you're trying to train a language model to work in today's society and you train it on newspaper articles from 1978, you're going to get very different language models. I mean, surf the web didn't mean anything in 1978, right? Language drifts as a data set. And so you have to think about that. Do you have a data set that drifts and changes over time? Because if so, your models have to adapt, or you'll train your model on this data set and it won't necessarily work very well. And it's always hard. There's a lot of tools on the market and there's a lot of competition for attention from those tools. So you have to figure out what tools to use. I could do a whole session on that at some other point. So yeah, that's it for my implementation answer.
Great. So a couple of the questions that have popped up here that I think are interesting here for us to think about. You know, one thing is like beyond sort of prediction and classification, how do we think about optimization? Jay Lopez asked this question, and the confusion in industry between sort of AI, ML, and sort of the traditional OR research-based optimization approaches and so forth.
Yeah, that's great. So there's a lot of AI companies that are working on things like logistics, right? And they do that because sometimes those algorithms tease things out of the data that a human might not have figured out or might not have seen, because again, getting back to the benefits of AI, it can just look at so much data. But you have to be careful. There's also a problem called overfitting, which is if your data is not balanced enough, the AI just learns the answer for that particular problem, right? So I don't have a sort of, unfortunately, like a good analogy to think about it. But it's one of the things if you're applying these projects that you want to be careful of, and that's a particular problem in logistics domains sometimes. And there are problems that AI can't solve. So, you know, so I sit on the board of a nonprofit called NEXI, the New England Complex Systems Institute. And there are a bunch of people that, you know, mathematicians that work on things that are sort of beyond AI, right? Where you're dealing with systems that have complexities in them that AI can't pick up on given sort of its current state. So you do have to be careful, but yeah, there's a lot of applications for optimization. One of the problems, though, is for a lot of optimization problems, the effort to apply AI to it may not be worth it for various reasons, right? Maybe too expensive, or, you know, I think we'll talk about this later, but, you know, you may need to be able to explain your answer. And sometimes with neural networks, you can't, because a neural network, you can think of it as a big grid of dots, and every dot has a weight. 0.3, 0.22, and like you don't know what those dots or those nodes mean. So, you know, JP Morgan was in the press last year for, you know, they came out with this credit scoring model that did way better. It was AI driven and it was way better than anything they'd had previously, but they decided not to use it because if somebody got rejected for credit, they couldn't explain why they were rejected, right? Because they might say, well, you're rejected because this node had a 0.4 on it. Well, what does that 0.4 mean? We don't know. So, and so in optimization problems, if explainability is important, you may not be able to use AI, you know, for it, because then if you know, depending on your use case, so going back to the credit scoring model, if you're now rejecting credit for somebody who's maybe a minority, and then they say, hey, maybe have I been discriminated against? Like, we don't know. And so you have to be able to explain that.
Great. And so just building on this further on the questions to ask, one is this sort of this ROI question that you know, it's really hard to predict the ROI of AI is going to be because of, how it might change the workflow, right? Like as you were explaining, like the graphics department, right? Are we going to create a PDF website, or are we going to create actually a responsive website? If you sort of saw the early versions of websites, they were basically PDF pages hosted on a web server. So the ROI is very difficult. So how do we get around sort of this, like, how do I explain ROI to some, seasoned executive that is always used to being hard-nosed and understands traditional processes, but doesn't understand the change in processes that may be enabled by doing ROI?
Yeah, boy, that's a great question. Some of the things that you can think about. So AI, you have to use a lot of analogies sometimes to try to explain these things to people. So I think if you can find some of those for your business, that can be really good. But in general, this is why a lot of people start with pilots, right? Because if you can get some function from the pilot, some economic idea of what the impact might be, it's less, in my experience talking to companies about this, they typically know what the impact might be if it works. The problem is they don't know how much effort it's going to be to get it to work, right? And one of the things you have to understand about AI and data science in general, right? So I would consider AI and data science sort of related fields. Some people would say data science is a branch of AI. Some would say AI is a branch of data science. I don't know. But it's not as well understood as engineering, right? So if you have a website that gets 10,000 visitors a month, and you're going to do a bunch of press and a new launch, and you expect it to get 1 million visitors a month, and you go to your engineering team and you say, okay, we need this to support 1 million visitors a month. They kind of roughly know what they need to do. They might be off by a couple of weeks here and there, and they might hit some hiccups, but they kind of know what needs to be done to make the website perform better. Now, let's say you have an AI model for something, and it's 82% accurate. And you go, well, 82% accurate is not accurate enough for this product. We need it to be minimum 91% accurate. Your data scientist probably doesn't know if they can get it to 91% accuracy or what it'll take. So it's hard to figure out the ROI because it could be like, well, they need a little more data. It could mean they need to try a slightly different neural network configuration. Or it could mean it's not predictable to that level, right? Some things are fundamentally unpredictable in nature at some level, and some things are fundamentally unpredictable given the data that you have. And so one of the hard things is, so you sort of have to approach it from a research perspective of like, okay, well, let's time box it for, why don't you work on another 6 weeks and let's see if you can go from 82% to what? Well, if in 6 weeks they go to 84%, you might say, wow, it's going to be a lot of work to get 91%. We can't do this. But if they get to 88%, oh, that's good. A little bit more work and they might get there, right? But you need to have a threshold for what success looks like and really understand how long you're willing to take to get there. And there's a competitive dynamic, right? People do things in business and sometimes you're forced to do things just to be, it's just the cost of doing business, and that'll inevitably happen for a lot of basic AI things. AI for supply chain, probably AI for customer support, AI for a lot of sales and marketing.
Rob, that's such a good point. That I mean, I think we can't ignore the competitive dynamics. It's kind of like, today you would never ask for the ROI of a website, right? You would say, okay, we need a website, we need to be there because everybody's on the web, and what's the ROI of social for companies as well? It's kind of like, that's almost like it's like oxygen. You don't ask about the ROI of oxygen or ROI of breathing for some organizations. And so I think it's a very interesting point. And the other point you're raising, and I think these are good issues, because there's some skepticism in the comments about, well, if you can't figure out the ROI, then maybe the ROI is going to be zero, and you should just admit that and move on, instead of trying to do some accounting tricks or so forth to come up with some crazy numbers to justify this to your executives. The other thing you mentioned is that for most organizations, this is still going to be an R&D effort. This is still going to be a learning effort to figure out how it applies. It's like, although many of the algos are off the shelf, that fine-tuning them and applying them to your particular context is going to be a learning journey. And you need to actually be thinking about that as a learning system as much as it is a product and engineering system that you're going to be putting out there for use by customers.
Yeah, I think you really, if you're at any decent sized company, I think you need to be experimenting with this stuff, even if your project fails or it looks like it doesn't have the ROI. This is coming, and this is a skill set that you have to master. And part of the way that you master it is by trying lots of things and learning what works and what doesn't. There's still a little bit of an art to it. And so, I think you see, that a lot of the companies that master new technologies at any given time, really benefit from those. And so, I think AI is no different. And then you have this other problem that AI techniques, they're moving very quickly. And so if you're not, particularly like I gave that flywheel example, right, of data and neural networks, like if you're in a competitive dynamic where your competition who has maybe a similar value prop and similar data set to you figures out that flywheel first, that could be the strategic advantage that sort of, sets you away, or sets you behind and lets them take off. There's a lot of debate. You can find a really good post about data network effects that was written by a VC named Matt Turk, who's like, hey, he's at First Mark Capital, and he said, data network effects are important, right? You have 1,000 pieces of data, and when you add that 1,001st piece of data, every other piece of data becomes more valuable. And then there's this post that came out last year from Andreessen Horowitz that you can read that's a counterpoint that says, the marginal value of new data can be low once your model's trained to a certain level. Don't get hung up on data network effects. And the truth is it's going to vary, business to business, right? It's like, how important is a website to your business? Well, if you're an investment management firm that caters to big, endowments and limited partners and stuff like that, like, your website might not matter that much. It's more of a static 5 pages. Here's what we do. Here's how to contact us. If you're Amazon, it matters quite a bit, right? If you sell stuff and everywhere in between. And so I think whether they're data network effects and whether they're defensible partially depends on your business, the data sets that you have, and what you're trying to do.
Great, thank you, Rob. So yeah, just on that particular point about data network effects, we will in the future have a whole deep dive on sort of this learning effects from data and where is it that this actually provides an advantage or not, and how to think about the value of data inherently. I think people sort of generically think of data as a new oil, but in fact, there's many different considerations about how to think about data, and our lab's doing a ton of research on this. I just got signaled that we have 20 minutes left, so I need to run faster with you, Rob. This is so interesting. I just want to, before we leave the slide, I want to just reflect on 2 additional questions that are of the same ilk that I think is worth it to ask here for people. Both Irina and Satya asked this question about, how do we think about building AI systems? Do we do it internally or do we leverage third-party solutions, right? And the balance between, building it yourself, sort of this classic, make versus buy decision. And then similarly, Satya asked this question, should you develop solutions? Should you develop pack solutions, yourself, or do you let the large platforms of the world do it for us? So certainly it's a different story if you're an AI company trying to enter the market and provide services. But for enterprises, how do we think about their AI investments and how much to outsource versus do themselves, and how to think about the relationship with the various platforms?
Yeah, wow, that's a big question.
Yeah, we could spend a whole session on that too. So by the way, just for everybody else here, look, we're covering a broad range of things. Your questions are going to help us as well to fine tune the next set of things we do. So this is supremely helpful, but I'm going to put Rob on the spot and ask us to give us at least an answer.
Yeah, so you really want to be thoughtful about this, because if you get it wrong, so I think probably the biggest example of this ever is a lot of people don't know that Google really got their start. Their breakthrough was they were the search bar on Yahoo for a while. And they were the search bar on Yahoo because Yahoo thought search wasn't going to be a big thing on the web, right? And so they were happy to outsource that to Google, which turned out to be probably one of the worst strategic mistakes in the history of, technology businesses. And so I think you have to think a lot about, I would encourage you to find some area to do AI internally. And the reason is that you want to understand it, right? Now, you might have to use external platforms and tools. You might have to use IBM Watson. You might have to use Data Robot. But I think you want to get some familiarity with this. And if you rely entirely on third-party people, you may not learn what you need to learn. But you also want to be careful about not investing in a commoditized area, right? If you're going to build, again, a customer support chatbot, it's probably not a good use of your time. There's lots of platforms to do it. I'm assuming automated support is not your differentiator in your business. So, why would you do that? So I would try to think about it, from a couple of those dimensions. And then I would probably ask myself, also, how much, what is the risk from a lot of the legislation around this is not out there yet, right? So sometimes there are cases where you might want to outsource something so that you don't have to deal with the data, or somebody else processes the data. So if you're subject to GDPR and you're doing facial recognition, or, or different things like that. So you might want, it's unclear for different types of AI models who's going to bear the liability when they fail. And so if there's some risk there, you might also want to outsource it, because you might want somebody else to bear that liability of getting sued because the AI model was biased or the AI model made a mistake. So I think it's a combination of things, but that's what I would look at, right? How core is it to your business? What is it called? Like, it's not a pure economic decision, because you have to think long term. Do you need you need to do some things because you need to learn about AI, and then where do you think the legal and ethical things, pieces of the industry are going, and making sure those matter as well.
Great, thanks, Rob. So let's move on to your final set of slides.
Yeah, so I get a lot of questions about, and we talked about this, before, what technologies are ready to use today. Because if you read, the AI news, oh my gosh, it's amazing, the stuff, they beat StarCraft video games and all this crazy stuff, and they beat humans at all these things. And the truth is, almost every headline you read comes out of a research lab for technology that is not ready to go into your business or anybody's business, really. These things are really hard to do. So let's talk about some things that do work now. Machine vision is very far along. If you have a machine vision application, identifying something, facial recognition, whatever, that's really good. Natural language processing, NLP, is really good for constrained domains. So what you have to remember about NLP, I don't know how many of you use Amazon Echo. I've had one for 4 or 5 years now. I feel like it's gotten worse as it tries to do more, because language is a very open-ended domain. And if you support a bunch of use cases and I say the word ARM, ARM, am I talking about my human appendage? Am I talking about an ARM computer chip that can go in a device? Is that an acronym for an adjustable rate mortgage in the finance industry? Like, you don't know. If your industry and your use case is constrained, like if it's a financial application, I assume when I hear the word ARM, you're not talking about your physical appendage. So NLP is really good if you have really constrained domains of language. And then this good rule of thumb that I talked about earlier, if you could write down all the rules, but it would take too long, it's probably a good thing for a neural network to figure out. Things that are on the forefront, autonomous vehicles. I don't think pure self-driving cars are anywhere close, but in terms of driving on the interstate and all that. Edge AI, so this is one of the most interesting fields to me. Is there are a lot of reasons to make your AI decisions at the, out in a device somewhere. So you could think about a camera that's programmed for facial recognition that doesn't have to contact the cloud every time. There are different reasons you might want to do that. Security reasons, you might not want to send that data back to the cloud. Latency reasons, based on your use case, if you're in a moving vehicle, it may take too long. And so, running AI models that are small at the edge is a big area where lots of really practical stuff is happening right now. And then advanced prediction via analytics. I think Kareem, you mentioned early on, this use case of predicting when a machine might fail for a manufacturing line. Like, these AI sensors and the sensors that you use can chug through a bunch of data and hear different sounds or see different patterns that the human hasn't picked up on yet. So I think that's pretty cool. And then up and coming tech that I would keep an eye on. So really moving beyond neural networks. So symbolic logic approaches to AI are going to is what's going to lead us to basic reasoning and stuff like that. And a lot of the work being done at both Google and IBM is about combining neural networks and symbolic logic approaches into what they call neurosymbolic AI. And then evolutionary algorithms for designing things. So, taking something and having the AI iterate on it, much like the process of evolution would, in a way that gets an outcome that you didn't expect, is pretty powerful. So you can use that for a lot of industrial design applications. NASA used it for a famous antenna design application where the AI created this antenna that has some funky, bendy design that no human would ever think to do. So there's some pretty cool stuff like that.
Yeah, there's a really good book by Pedro Domingos called The Master Algorithm, which goes through sort of what he calls the 5 tribes of AI. Certainly the statistical approach is one approach, which has sort of taken off. at the base. But there, you know, as Rob's pointing out, the symbolic approaches, the evolutionary algorithms, those are all also sort of at the moment, you know, lots of research is going on. We haven't seen their killer applications come out yet, but that book really sort of provides a fairly decent introduction to sort of the broad scope of sort of the computational approaches that are being taken here.
Yep. So I think that's all I have on this. Are we ready to open it up for more questions?
Yeah. Rob, why don't you? You know, we have about 12 minutes left. So why don't you finish the deck, and then we can you know, round up the conversation.
Sure. So some implementation challenges that we already mentioned, sort of culture and workforce related, business model related. I think, you know, we mentioned before the services to software switch. And then practical concerns. I think we've hit on these, right? Data quality. Do you have the data to do what you want to do? You know, and this may require, this third point here, it may require some strategic trade-offs, because not all your data is going to be used just for AI applications. So do you want to go through the effort to structure how you store and manage data? Again, it's the ROI. Is it going to be big enough? Is it going to interfere with other applications of the data? Are you going to get the value that you want? Is something to think about. And then explainability, right? So neural networks are black boxes. Biases can creep in, even if you try to keep them out. You think, oh, I'm not going to encode race at all in my data. It doesn't matter, right? The neural network might pick up, for a credit scoring model, might pick up, you know, zip code, or it might pick up that, you know, a last name is Hispanic, and maybe it creates a bias against that. Like, we just don't fully understand how these things work sometimes, which is dangerous. So you have to, sometimes you have to look for simpler types of data science. One of the biggest pieces of advice I can give you is, do you really need a neural network? Like, you should think long and hard about that and understand if a simpler type of data science, logistic regression, support vector machines, things like that can solve your problem. A lot of times they can. And so this is me. My, you know, you can email me, rob@pjc.vc if you have any questions, or find me on Twitter. And then if you want to check out my AI newsletter, inside.com/AI. Every day, somebody else, not me, writes the AI news. And then on the weekends, I write commentary about what's going on in the AI industry.
Great, Rob. So let's maybe why don't you tell us? You know, we're getting a lot more questions, but I want to sort of tell us a little bit more about sort of what you've seen, sort of exciting investments you've sort of seen in the companies around AI. Because I think, again, with the context of, like, many of the startups are, of course, going to serve enterprises, and so what are you sort of seeing that have sort of, like, said, oh, this is interesting, or this is something new that have come about? The ones you've invested in, and the ones you might have missed, and you said, oh, that was a false negative.
Yeah. So one of the first theses that we were turned on to when I joined PJC, we're a generalist firm, but my personal focus is AI and robots. And one of the first investments I made was in a company called Synthesis.ai, and they're a synthetic data company. And I think this is a fascinating area that is going to become bigger and bigger and bigger, right? And so the way to think about it is, if you have an iPhone that unlocks by looking at your face, that's a machine learning model that's running that, and it's giving out a score. I'm 94% sure that's Rob. I'm going to unlock the phone. Well, those models over time are going to go in and out of calibration, right, as they get more data. And these models are going to be in everything that you do. And so what happens when they go out of calibration? Well, let's say it doesn't work you're getting your Apple, and you're getting a bunch of reports that, like, it doesn't work well in bars where the lighting's low, or it doesn't work when it's raining out and somebody tries to unlock their phone because the raindrops get in the way and smudge the camera or whatever. Well, how do you fix that? You fix that by going to get more data samples like that to train the model. Well, that's expensive, right? You want to go out and take 10,000 more pictures of people's faces in bars, low lighting. You don't have to do that. You can use synthetic data, which is, you can take one photograph of me, and you can put different facial hair on me. You can put glasses. You can change my hair. You can change my hat, all with Photoshop. And you can make, 1,000 different versions of my face and put those all in the model. And as long as it was derived from real data and worked within natural constraints, now you have more data to train your model. So Synthesis AI is building into workflow tools for everybody to do stuff like that. So another example would be, you're picking stuff out of the trash, right? You have a robot that picks recyclable things out of trash. Well, the problem is, if I have a crumpled up cardboard milk carton, there's 100 different ways I could crumple it. It could be laying next to 1,000 other different items, right? And I don't want to go out and get, 100 crumpled milk cartons, take pictures of them laying against glass bottles and cans and other crumpled milk cartons and whatever, so that the thing can figure out how to pick them up. So I can synthetically generate a lot of those, right? I just need a couple of pictures of crumpled milk cartons, and then I can Photoshop those. This is the way to think about it. That's not really what they do, but think about it as Photoshopping them into lots of pictures of garbage, and auto-generating like the bounding box that says, hey, here's the milk carton that you're picking out. So now I suddenly can generate hundreds of thousands of examples synthetically to train. And this came out of self-driving cars, which was, can you build fake cities and have the cars drive through it? They still need to do some real world driving, but if it's a matter of data, like, can they drive through these synthetic cities and learn a lot? So I think synthetic data is one of the things I'm most excited about.
Yeah, and I recently heard, Rob, also like even in medical imaging as well, because there are some fractures or some conditions that are pretty rare, right? But they're well understood by the medical profession. Like when you see it, you'll know it's X or Y or Z. So you can actually then also generate synthetic data to train the models that way too, because that's a known condition. And I think that's a very interesting, again, it goes back to our prior discussion about the value of data. Right now, if you can generate synthetic data, right, and that helps build your model accuracy, that does one thing. Versus, do you have access to the flow of data in order for you to be able to run a business around this as well? So that's a very interesting thing. And then of course, Suresh is asking in the chat, like, is are deepfakes synthetic? Exactly, deepfakes are generating using real data to generate a synthetic face. And so there's a whole blurriness of this that's going to be going on.
Yeah, so that's going to lead to, I think there's going to be a whole industry that I would call synthetic media, right? Which is, so think about this. Think about if you're a TV station and on the website, you want to generate, you want to take a video of your weatherman and you want to just generate, every hour a new forecast as the forecast changes, and then put up a little video of that you should be able to take the one video of the weather person and then feed it a stream of changing weather information, and using deepfake-like technology, generate a new video all the time where it looks like, man, this weatherman works 24/7 and is just always on top of the latest, things. Or think about it if you have a how-to video or customer support things, like you're Progressive, right? And you have Flo, and she's your brand, and you want Flo to help you in the customer support chat. Well, what synthetic media can do will be, every time you upload a new support article, it automatically gets generated into Flo's brain, and she can talk about it and everything else without actually filming whatever that actress's name is, doing it. So I think synthetic media is going to be a big field. There's going to be a lot of problems, right? I mean, I think we'll skirt most of them for this election, but man, whatever the 2024 election is, it's going to be like a battle of synthetic media. It's going to be bad.
Yeah, absolutely. No, and I think hopefully in the future we'll also get Sinan Arl, who's a friend of mine and a faculty member at MIT, who has a book coming out called Hype Cycle, which is going to talk about basically how social media, which is powered by algorithms, is going to have a big impact in all that we consume, including all this fake stuff. So I think it'll be very interesting. So Rob, in the 3 minutes we have left, any final sort of words of wisdom for our practitioners that are here with us on the session on how to start thinking about AI going forward?
I think a lot of the, a lot of the great strategic thinking over the years has come out of Harvard, right? Particularly a lot of the Michael Porter stuff. And I think when you think about Porter's 5 forces, when you think about value chains, there aren't a lot of people applying those AI to those concepts. And I think I would still think strategically about your business, and I would think AI about an enabling technology, and where it can shift those industry forces, or where it can shift and impact your value chain. And again, don't think about this as like, hey, I have this value chain, this workflow, and I'm going to attack AI at the end. But like for every step, right? If your classical strategic thinking says that your value chain should have some steps that are differentiated from competitors based on the customer segment that you go after. Well, where those steps in the value chain where you can apply AI to increase that advantage is something I would think a lot about.
Right. So Rob, if you could stop your share, I have one final request of our audience. So what we're going to do is we're going to take a photo of all of you and then stitch it together in a giant picture. So make sure your videos are turned on for like 30 seconds, if you don't mind. and then I'll get the team to take a screenshot of every screen. We have 196 people. Stick around for a few seconds. So that I can show ROI to my dean, about why are we doing all this work. So stick around for 30 more seconds, and I'll wrap up. But let's make sure we have you guys as photos. Maybe wave, give a thumbs up or thumbs down if you didn't like this thing. Keep giving me thumbs up. Yeah, we like 5 stars in all of our ratings. And so again. It's really fantastic to see all of you show up. Again, this is the beginning of our monthly series here that we'll be doing. We'll be, reaching out to you by email, getting your suggestions and feedback on how to improve this process. We really want to build a community around this. And if you have suggestions for additional folks for us to invite, please do so, and we'll do our best to get them with us. And finally, again, I want to thank Rob for helping us launch this and kicking this off so well. Please do subscribe to his newsletter, and then I'll be sure sending my book to Rob as well, so he knows what thinking is coming out of Harvard around AI as well. So with that, again, everybody stay safe in these crazy times, and look forward to chatting with all of you soon. Take good care.